Imagine standing still, feeling the solid ground beneath your feet. Everything around you appears calm, unmoving. But what if I told you that even now you're part of a cosmic journey, moving through space at unimaginable speeds? We're not just passengers on Earth. We're hurtling through the universe on multiple levels, caught in an incredible web of motion that we rarely even think about. Right now, you're rotating along with the Earth at over 1,600 kilometers per hour. The entire planet is orbiting the Sun at a staggering 107,000 kilometers per hour. And that's just the beginning. As a solar system, we're speeding around the center of our Milky Way galaxy, moving even faster at about 828,000 kilometers per hour. If that sounds fast, consider this. Our galaxy itself is racing through space toward other galaxies at over 2 million kilometers per hour. When you add all these speeds together, we're on a dizzying, non-stop journey through the cosmos, even if we never feel it. But how do we begin to understand these speeds? And what about time? How is it that you and I experience time in the same way, even though we're moving so quickly through space? The answer lies in a revolutionary idea that changed science forever: Einstein's theory of special relativity. Einstein discovered something incredible. The faster we move, the more time and space warp around us. At certain speeds, time actually slows down and distances contract. This means that our perception of time and space isn't as constant as we once believed. It can change, and dramatically so, depending on how fast we're going. Let's dive into the layers of motion that make up our journey through the universe. First, there's Earth's rotation. Even when we're standing still, we're spinning with the planet at around 1,670 kilometers per hour at the equator. But that's just the beginning. Our planet is also orbiting the Sun, carrying all of us at a jaw-dropping speed of 107,000 kilometers per hour. Imagine speeding around in a car at that rate. Only, there's no finish line in space. But it doesn't stop there. Our entire solar system is in motion, orbiting the center of the Milky Way galaxy. This adds another layer, as we're now moving at about 828,000 kilometers per hour. And even the galaxy isn't sitting still. The Milky Way is hurtling toward other galaxies in the local group, moving through the vastness of the universe at over 2 million kilometers per hour. These numbers are mind-bending, but when you add them up, you begin to realize we're part of an extraordinary cosmic dance, moving faster than we could ever perceive. How does this all fit together? Why do we feel still while moving so fast? To answer that, we need to go back to the early 20th century, when Albert Einstein introduced a theory that would change everything. Albert Einstein was a scientist who wasn't afraid to think differently. In 1905, he introduced a concept that would transform our understanding of space, time, and motion. At the heart of his theory were two remarkable ideas. First, he proposed that the laws of physics are the same for everyone, no matter where they are or how fast they're moving, as long as they're not accelerating. This was a radical notion, but it makes the universe a more orderly place. Then came his second idea, that the speed of light is constant. No matter how fast you're moving or what direction you're going, light will always travel at 299,792 kilometers per second. This constant speed would go on to become one of the foundations of physics. These two simple ideas, that physics is the same for all observers and that the speed of light never changes, laid the groundwork for what we now call the theory of special relativity. But what do these principles mean for us? They mean that at high speeds, space and time themselves begin to warp and bend in ways that defy common sense. One of the most astonishing consequences of special relativity is time dilation. Imagine you're on a spaceship traveling close to the speed of light. For you, time would feel normal, but to an observer watching you from Earth, time would appear to slow down for you. In other words, the faster you move, the slower time seems to pass for you compared to someone who's stationary. This effect grows stronger as you approach the speed of light, to the point where if you could somehow reach light speed, time would stop entirely. Then there's length contraction, an equally strange idea. When you're moving close to light speed, objects in the direction of your travel actually appear to shrink. Space itself seems to compress. These effects may sound like science fiction, but they're fundamental aspects of reality that physicists have observed time and time again in high-energy experiments. Special relativity reshapes our understanding of the universe, showing us that space and time aren't fixed. They're flexible, stretching and compressing with speed. In short, reality is far stranger than it seems. Einstein's theory isn't just a mind-bending idea, it has real-world applications that affect our everyday lives. GPS satellites, for example, are constantly moving at high speeds around Earth. Because they're moving so fast and are far from the planet's surface, time passes a little differently for them than it does for us on the ground. Scientists have to adjust GPS clocks for this difference in time, or else our navigation systems would be wildly inaccurate. Special relativity also applies in the world of particle physics. In particle accelerators, particles are sped up to nearly the speed of light. At these speeds, the particles' lifespans actually stretch out, allowing scientists to study them in greater detail. And finally, cosmic rays, high-energy particles from deep space, are only able to reach Earth because of time dilation. By traveling close to the speed of light, they cover vast distances before decaying. These real-world effects remind us that special relativity isn't just a theory, it's a fundamental part of how our universe works, with effects that we can observe and measure right here on Earth. So, here we are, part of a complex web of motion, experiencing time and space in ways we barely understand. We're moving through the universe faster than we can comprehend, and yet, we feel perfectly still. Thanks to Einstein's theory of special relativity, we now know that space and time are far more mysterious and flexible than we once believed. Our journey through space reminds us of just how small we are in the grand scheme of things, but also how connected we are to the cosmos. In the end, learning about our speed and relativity offers a humbling glimpse into the fabric of reality, showing us that the universe is far richer and stranger than we ever imagined. If you enjoyed exploring the mysteries of motion and special relativity, don't forget to like, subscribe, and hit the bell icon for more cosmic journeys. Thanks for watching, and I'll see you in the next video.